welcome to our FloEFD webinar. And of course, thank you for taking time out of your day to be here with us. We really appreciate it. Today we have Jason Walker, one of CamLogic's application engineers, who's going to be presenting and walking us through some demonstrations and slides. Before we get started, I did want to provide a summary of CamLogic for those of you who may not be familiar with our organization. CamLogic is a holistic engineering solution provider, leveraging PLM software, manufacturing, and quality control. Our success is a result of a long-standing commitment to our customers, our region, and the industries we serve. Our business model, or our wheel, as you can see here, illustrates our go-to-market approach in 4 value-driven offerings. We start with Conceive, which is our engineering and design team. Moving on to Develop, which includes our Siemens software offering. And Manufacture, we are a tier 1 supplier that leverages both the Conceive and Develop to deliver customer solutions. And finally, Capture, which is our quality control group that makes sure that those solutions are of the highest quality. I'm just going to run through the agenda real quick, and then I'm going to pass things over to Jason. So we are going to start with the benefits of simulation, then go into what FloEFD is, and then move on to a few demonstrations led by Jason, and we'll finish off the presentation portion by talking about some of the add-ons to FloEFD. We'll then, of course, go into an open Q&A, followed by a limited time offer announcement for Solid Edge simulation. As per usual, in regards to the Q&A, everyone feel free to put any questions that may come up in the chat or in the Q&A area during the presentation, and we will be sure to start with those when we get to Q&A. And with that being said, I'm going to hand things over to Jason now.
Thanks, Ashley. Like we mentioned, I am going to talk about and demonstrate FloEFD for Solid Edge and NX. But before I get into FloEFD specifically, I want to talk a little bit about simulation software in general and also about simulation-driven design, which is putting simulation in the hands of designers and kind of using it earlier in the design process. Currently, simulation software offers many benefits. It has reduced the need for physical prototypes. You don't have to build and break several designs just to see if they're feasible. This significantly lowers the cost of development and speeds up the development process. There's also been some difficulties, though. It has become a very complex process that requires specialized tools and often multiple experts to use those tools. This led to a process where designers create a design, pass it off to analysts who would then provide feedback on the design. However, there was often long wait times before the designers got their feedback because simulation can be complex, and often there's also more designers than analysts. So this is kind of how that process would go. Designers create their initial design, they send it over to the analysts. Like I said, simulation can be time consuming. So while the designers are waiting, what do? They make more designs, usually basing the subsequent designs on experience and educated guesses. When designers would get their feedback, it was often for designs that were no longer current. One way to improve this process is by implementing simulation-driven design. In other words, using simulation earlier and more frequent in the design process. By using simulation-driven design, it's possible for designers to even use simulation to help determine your initial design shapes. After creating the initial shape, you can run simple simulations frequently throughout the design process, and it will provide feedback on each design iteration. The designer can create more reliable components this way by validating their design changes with the simulation software. And it also benefits the analysts because they're able to focus on some of the more complex simulations. As most people know, designers can be very costly. The further into the design process that an error is discovered, the more expensive it's going to be. simulation-driven design reduces these costs by using simulation earlier on, so that there are less issues, and issues that are present will be discovered earlier. Putting simulation into the hands of your engineers enables them to validate their designs more frequently. This allows for the creation of more concepts, improves the quality of those concepts, and reduces the overall design time. When surveyed about changes in their performance, most organizations noticed about a 21% drop in the number of change orders. They had to build 27% fewer prototypes, and overall design time had been reduced by about 29%. After talking about the benefits of design level simulation, I wanted to talk about the different software that's available in both the Solid Edge and NX portfolios. On the Solid Edge side, we have some simulation capability available in the premium license. There are also Solid Edge Simulation Standard and Simulation Advanced licenses, each one having different levels of capability. Of course, this presentation is about Simcenter FloEFD for Solid Edge. There's also Simcenter FlowMaster for Solid Edge. On the NX side, we have various simulation licenses available, some in the product design and others in the design validation categories. All of the simulation for NX are available in the NX design value-based licensing options. As I mentioned, today's presentation is mostly focused on Simcenter FloEFD for Solid Edge and NX. However, if you do have any questions about the other simulation capabilities in either portfolio, please let us know. Now I want to talk about Simcenter FloEFD for Solid Edge or NX. FloEFD is a powerful CFD software that is built into your CAD environment. So the same place where you design parts and put together assemblies, you are also able to simulate fluids, flows, and thermodynamics. This has applications in many industries, for aerodynamics in the automotive or aerospace industry, maybe in hydraulic components for heavy machinery, so on. So now I'm going to do a demonstration of Simcenter FloEFD. I will be using this software inside Solid Edge 2024. But before I do that, I wanted to mention that the UI and workflows are basically the same in both Solid Edge and NX. The differences are very minor. So this demonstration is for both audiences. So I will start by opening up Solid Edge and opening this assembly for an audio amplifier. We can use FloEFD to simulate the airflow through the case and see how well and the fan is cooling down the electronics within the case here. So you'll notice that I have a couple of additions to what you'd find in a typical Solid Edge install. First is that flow analysis tab and the analysis pane on the left side. And I'm going to use the wizard to start this simulation. The wizard is a guided, step-by-step process to set the basic criteria and basic parameters for your simulation. So once I've input all these starting and base parameters, I can then move on to defining some of the more specific parameters for certain pieces of the certain components of the audio amplifier. The box that is placed around the assembly is the computational domain. That is something that was calculated automatically and shows the 3D space or the volume that is being considered for the simulation. Now I'm adding some more specific materials instead of everything defaulting to the aluminum for the solid material that I had chose. And I'm setting the PCB to, or the control board to be PCB, and these transistors the appropriate material as well. Next, I'm going to add some conditions for the vent or the exhaust. By adding some geometry there, you can define the surface of those objects as the exhaust area. And now that that's been applied, I can then add the fans. So what I'm doing is basically just going and completing all the other parameters for my simulation, and I'm selecting all of the geometry that I want to apply these parameters to right from my CAD model. So it really is an extension of your existing software, and it makes it really easy to integrate, and you don't have to do any exporting, importing, translation. You can do all of this right inside Solid Edge or NX. So I've defined my fan, and now I need to define a couple of heat sources. I can select the solid materials that I've already defined, so the PCB and the transistors. I can rename some of these parameters as well to make it easier to follow later. And then lastly, we need to add a couple of goals, and these are what determine when the simulation is considered to be completed. So the first will be the temperature of the transistors, and the other will be the maximum flow rate of our fan. Next, we can go to the global mesh, and this is where you can define how it will mesh. Mesh has frequently been sort of a difficult and a bit of a limiter in when it comes to CFD. However, the built-in meshing approach for FloEFD makes it very easy, and it can handle a lot of complex and a wide variety of geometries pretty easily. So it doesn't take a whole lot of effort in order to get a good simulation mesh. So after the simulation had been run, which I did ahead of time, we can see the results. First is our control board. We can get the temperature of the PCB, and you can see with that the colors correlate to temperature. We can also use the probe command to get specific temperatures in specific areas. Additionally, we can take a look at the actual flow trajectories of our airflow and what's being generated from the fan. We can define this as the air coming from our fan, and it makes it really easy to visualize what is occurring with our airflow. So in this case, we can see that the center of our PCB is extremely hot, way hotter than it can be for standard electronics. And what we see here is that there's a large concentration of that airflow on just the outside of the case. You can see the velocity and the amount of air being moved in that central region is very small. So what we can do is stop these visualizations and take a look at some of the other make some adjustments to our model and see how that fixes the situation. So what you'll see here is the fan. It moves over to the left a little bit, and we made our heat sink just a little bit bigger. And now we'll look at the results of this simulation that I have run ahead of time and see what the differences are. Simulations with a slightly different geometry than the previous simulation. And now we can see that our PCB temperature is a lot more acceptable than it was on the previous iteration. We can still use the probe command to see the specific temperatures in that hottest area. And we can also use the flow trajectories again to see why this is so much different than the previous one. So you can see now that the amount of air that is flowing through the central areas of the amplifier case is a lot more. You can also see that the air that is moving through there is moving at a higher velocity, and this is causing that temperature to be significantly lower than in the previous simulation. And so this shows how easy it is to quickly identify and make adjustments to your assemblies, your models, and get verification that your solutions are moving in the right direction. We also have the compare option, which will show us those two different simulations side by side. So if I compare those two studies and show the PCB temp, I'll make it a little bigger here. You can see the two different temperatures in the two different studies side by side, and it will show you the different temperatures and how much better it was cooled in that second iteration. There's also some output options for utilizing this in something like a report.
In addition to heat transfer and fluid flow simulation, there are a few modules available for FloEFD that add additional capabilities. These are the electronics module, the lighting module, and extended design exploration. Today I'm going to show two more demonstrations, one for lighting and the other for electronics. For the lighting demonstration, I have an assembly of an LED lamp. It has 6 individual LEDs inside the assembly here. Just like with the previous simulation, I've already have everything predefined and I've run the simulation. This is just to save some time. These do take a little while to run. I'll load the results, and also similarly to the previous simulation, we can still see the fluid flows, or the airflow in this case, and the temperatures of the air as well. We can see that the air near the light assembly is the warmest, and the air outside is cooler. Most of the hottest air is concentrated near the electronics, as we would expect. Now, the lighting package that I wanted to show off a little bit allows you to simulate the actual lights from the LEDs. You can see that this is a portion of basically a sample of the rays given off by the LEDs, and it shows the energy levels and how they bounce, the angles they bounce at, so on and so forth. For the next example, I'm going to use a transformer assembly. This is a good model to show what can be done with the electronics or electromagnetic capabilities. So Just like the previous simulations, I have run these in advance. I am loading the results. One of the things that this module allows you to do is simulate for things like the magnetic flux, the intensity of it. You can see that I have the flux lines, and then the colored graph is showing the intensity of the magnetic flux within the magnetic field. And then alongside that, you can still, of course, do the simulations for both fluid flows and heat transfer. This is just another example here of how you could visualize the results. That is showing the temperature on the surface of the core. And then, of course, like the other ones, we can still show the flow of fluids, in this case, the air rising up through the transformer assembly. Hiding the assembly here makes it a little bit easier to see. So as you can see, with this demonstration and the lighting demonstration, the modules for FloEFD add a little bit more capability and versatility to your simulation portfolio. Hopefully these gave you a few ideas of how those additional simulation capabilities could be used. I'm going to pass it back over to Ashley here and for the Q&A and some other announcements.
Okay, thank you, Jason. So we are now going to move into our open Q&A. So if you haven't done so already, go ahead and put your questions into the chat or the Q&A area.
Yeah, this add-on is available for all versions of Solid Edge. So 2023, 2024 are both. Sorry about that. Yeah, they're both valuable or viable options for the FloEFD add-on. Sorry about that. The question was whether it could be added to Solid Edge 2023.
All right, so another question. Can FloEFD results be exported to a stress analysis system?
Yes, so the FloEFD results, they can be exported to multiple structural simulation programs or FEA analysis, and that includes, of course, simulation capabilities already in Solid Edge. There's functions to move the results of FloEFD right into your FEA simulations.
All right, another question. Can you share the pricing?
So on our next slide, we actually have the limited time offer, and Ashley will go over that in a moment. However, if you do have any, we can't share any specifics over the webinar, but if you do have questions about pricing, you can contact sales or one of our account managers so that we can get the a proper quote over to you.
All right, we'll give another minute or so for anybody to get questions in there, and then we'll move on to the limited time offer. All right, so I think we've got probably about all those questions have been answered. Of course, to all the attendees, if you have any more questions after the webinar and you maybe think of something later on, of course, feel free to reach out to Jason or our sales team, and we'll be sure to get you the answers that you're looking for. And we'll have both of those emails and phone numbers up at the end of the presentation too, for anyone to jot down if you want some of that contact info. Moving on to our simulation limited time offer. We do have a promotion running from June 1st to September 31st of 2024. During this limited time, you can get up to 35% off Solid Edge simulation products. This is going to depend on your length of the term, the quantity, and the product requested. To anybody who is interested in NX pricing, you can go ahead and contact us or drop your name in the chat now if you wanted to, and we can have a rep contact you directly. The included products for the Solid Edge simulation limited time offer include Solid Edge Simulation Standard, Solid Edge Simulation Advanced, Simcenter FloEFD for Solid Edge, Simcenter FlowMaster Static Module for Solid Edge, and Simcenter FlowMaster Dynamic Module for Solid Edge. Also, we just wanted to talk about the various trainings that are available via Accelerator Academy that offer specialized learning paths for Simcenter, FloEFD, and Simcenter. These are designed for various skill levels. So the curriculum spans from introductory courses to advanced simulation techniques and industry-specific applications. If you would like any more information about training or maybe pricing, please feel free to reach out to our team. We're always available, and we're more than happy to help in any way that we can. That is going to officially conclude our FloEFD webinar. Again, thank you all for being here today and spending some of your time with us. We've got Jason Walker's email and phone number, as well as our sales team contact info here. So please do not hesitate to reach out with any questions that you may have. So everybody, have a nice day. Thank you so much.